Great. Hi, everyone. I'm David Wilson, co-founder, CEO of Cape. We help network admins and IT managers at MSPs, stadiums, hotels, all kinds of other enterprises ensure their networks enable a great experience, a great connected experience for their users. We're going to talk about our product, and we're going to do a demo of some new features. But first, I want to tell you how Cape came into being. So I started Cape just over 3 years ago with Fuad, who's going to be talking next, and Ross and Mike, who are based in South Africa. 4 of us are software and RF engineers. We'd spent a number of years working with frontline engineers up to CTOs and boards at large global mobile carriers. Initially designing, building, and operating wireless networks, and then developing ways of harnessing the huge amount of data that the networks generate and other parts of those organizations generate to help those CTOs and CEOs optimize billions of dollars worth of network investment. But no matter how much data we extracted, and in fact, on one project, Fuad and I spent 5 months gathering data and crunching data from 70 different systems, we just couldn't answer fundamental questions about the network that everyone who runs a network wants to know. How good is my network? How should it be better? And what does it even mean to be a good network? And that's because the network data can't tell you that. Only users can tell you that. A good network is one where users have a great connected experience. In other words, users experience great application performance in most instances. So the only way to actually measure user experience is to be a user. So we decided to build one. 4 of us quit our jobs. We moved into a basement in Cape Town, South Africa. And I'm going to pull back the curtain a little bit into what it was like kind of turning a nerd dream into reality. I'm going to show you some pictures that we actually haven't shown anyone before. This is the inside of the basement, aka the pit, where we spent day and night prototyping hardware and software. Of course, we started with a Raspberry Pi, and we wanted to add wireless dongles. But Linux drivers are notoriously bad, so we bought every single Wi-Fi and cellular dongle that we can find and tested them all. Because we were carrier guys, we wanted to test cellular networks as well. So we started prototyping hardware to multiplex SIM cards. But we were prototyping so fast that there was nobody who could produce the circuit boards fast enough for us. So, as you do, we built our own solder reflow oven from scratch to do all the soldering for us. Now, pro tip, especially for everyone watching this from home, don't try this yourselves. Don't try building a computer-controlled oven, especially out of wood. Fortunately, Mike is a firefighter, so spoiler alert, we all lived. But we deployed a handful of these prototype sensors in glorious lunchbox form factor in friends' houses. And they worked great for a few days. We found that the Raspberry Pis inside just failed. The SD cards got corrupted. The USB dongles just simply weren't reliable enough to really count on over a long period of time in a remote location. So we went back to the drawing board. We were lean and mean, so we used off-the-shelf components wherever we could. We used an Odroid for the brains, but we had to build custom electronics for a kind of new form factor. We built a custom USB hub to make the dongles behave. We built a custom power supply board for PoE and some other custom electronics to add functionality and reliability. And it worked really well. We made almost 100 prototypes, and we sold them all very quickly to wireless managed service providers. So we knew we were really onto something. Fortunately, it was painstaking to assemble these things. This is a rare photo of Fuad actually doing some work. We were software engineers, not hardware engineers. And we knew we needed to learn about making hardware at scale and raise capital to finance that. So we moved to Silicon Valley. We went to an accelerator program for hardware startups. The four of us lived together for 4 months in a tiny apartment. Also spent time in China working directly with manufacturers. And 15 months ago or so, we raised venture capital from some awesome VCs. I really couldn't be prouder of what the team has achieved since then. We've taken some complex circuit boards that took forever to assemble and turned it into a single, really beautifully designed PCB that can be manufactured at scale. We took something that looked like a brick that I wouldn't even want in my closet and turned it into a sleek device that you can install near users. Whether they're in schools, malls, retail stores, hotels, warehouses, stadiums, offices, and we've got customers in all of those environments. But doing our own hardware means we can do some really awesome things. So inside this device, here's what it looks like in person. It's reasonably small. We've got a really powerful processor that runs a full Linux distribution. You can power it either by PoE or by 12 volts. It's got a power backup inside there, so you don't lose touch of the sensor if power gets pulled for some reason. It's got dual band MIMO, Wi-Fi, gigabit Ethernet, but the gigabit Ethernet is not required. And that's because in every one of these, we've also got a cellular module with a fully managed SIM card. And that enables us to make it really, really easy to install these devices. You can save money on cable runs, which can cost as much as the hardware themselves. And there's no tool, you don't need tools to mount it because there's adhesive on the back of the mounting plate. In fact, it's so easy to install that we've had customers mail it out to remote sites and have receptionists plug it in, and it gets on the dashboard within 2 minutes. I've spoken a lot about the hardware, and the hardware is awesome and hardware is fun, but really what makes it work is the software. And that's where our strengths lie. From the custom firmware up, we've engineered the sensor software to be remotely upgradable. And there's lots of features in there to make it resilient so that if there's a bad update or it loses power during an update, it rolls back to a previous version. It can recover itself. It's really robust. And much of it is portable to other platforms as well. And we're adding functionality all the time. Since WLPC, where I met a lot of you, we've made 275 updates to the software. So that's just a handful of months. And we've added tons of new features. 42 major new feature releases. But just like the software on the sensor makes the hardware work, it's the software in the cloud that makes the sensor work. And we built our cloud on market-leading cloud services and technologies, predominantly Amazon's cloud and Google's cloud platform, as well as some other really exciting technologies that are pushing the market forward. So you can think of this sensor as the tip of an iceberg because you can see it, but really underneath this, making this work is so much more. This is just a small part of what's there. And I could spend the whole session talking about our cloud, but I just want to touch on a few points. The comms from the sensor to the cloud are all encrypted and secure. We've got a mix of very fast databases as well as databases for long-term storage. We store data basically indefinitely. We've got full load balancing and redundancy. We actually create separate databases for each one of our customers to make sure the data is kept separate, even though we don't have any private data collected by the sensor. And we've hooked up everything with a layer of APIs. So why did we design everything this way? This sensor is a first step, and there'll be many other things uploading data to this cloud platform. And we've designed this architecture to scale to millions of data sources and different kinds of data sources. Likewise, we've built out our APIs to build integration and automation into some of the leading networking vendors, as well as monitoring systems, ticketing systems, and other things. So we'll give you a little taste of that later. But in a world where Wi-Fi is getting smarter but more complex, and so are networks, clouds, and even applications, none of those things are talking to each other. And someone needs to be looking after that end-to-end user experience, and that's us. But today, all of this architecture and all this engineering is what it takes to make this. Looks really simple, but underneath it has a tremendous amount of data, tremendous amount of capabilities. Fuad will show you some of those a little later. But before he does, I want to answer the question, why did we hide all the awesome metrics and charts and use 5 traffic lights? And why did we try and rethink what the network dashboard should look like? There are just over 200 CWNE certified wireless experts, but there are millions of enterprise Wi-Fi networks. And that means that 99.99% of networks are not run by the top certified Wi-Fi experts, right? And we want our product to be valuable for those experts, for people like yourselves, but it's designed for people who are not necessarily experts. People who find dashboards with hundreds of KPIs intimidating, people who don't want to spend time learning complex new tools, figuring out how to make sense of all the data themselves, who don't want to spend days configuring new products. But that said, everyone is still responsible for running wireless networks. Everyone still has wireless users that depend on them. Everyone still has bosses who are demanding. Or perhaps they are experts, but they've got lots of different sites and they can't be everywhere at once. So no matter who it's run by, every network is becoming mission critical. Every network needs someone to look after the user experience. So we think every network should have